Imagine a building, not one of glass and steel from the 21st century, but one crafted by hands thousands of years ago. Imagine that building standing tall, year after year, defying everything thrown its way. The relentless hammer of time, the biting winds of the desert, the furious shake of the earth. How is it possible? Look at the modern world around us. Our buildings, monuments, and bridges, masterpieces of contemporary engineering, often require extensive, costly maintenance to survive just a few decades. Yet structures like the pyramids of Giza, the Roman Colosseum, or Machu Picchu still dominate their skylines, centuries and millennia after their builders laid the very last stone. This isn't just a question of history, it's a fundamental engineering mystery. How did civilizations without steel girders, without computer models, and without powerful cranes manage to create structures that possess a level of durability that often exceeds our own? It's a riddle whispered by the stone, a secret hidden within the mortar, an act of defiance against the endless march of decay. We often look at ancient ruins and see only destruction. We see the crumbled walls, the missing facades, the empty spaces. But what we should be focusing on is what remains. The incredible, unwavering endurance of those core structures that simply refuse to surrender to the sands of time. This is not about accidental survival. This is about intentional resilience. In this journey, we are going to expose the mind-bending reality that civilizations thousands of years ago built structures more robust, more sustainable, and in many ways, more resilient than anything we construct today. We will peel back the layers of history to uncover the forgotten genius, the seismic-proof foundations, the miracle materials that self-heal, and the architectural geometry that laughs in the face of gravity. Prepare to have your perception of history and human ingenuity completely revolutionized. This is Surviving the Sands of Time, Resilient Ancient Structures. Get ready to uncover the unbelievable engineering secrets that allowed these ancient marvels to literally last forever. We marveled at their survival, but to truly understand the genius of the ancients, we must first confront the sheer scale of the challenges they overcame. Imagine a colossal siege that never ends, an enemy force that never tires, attacking day and night for thousands of years. This is the truth of time. The greatest architectural feats were not defeated by rival armies, but by the slow, unseen, relentless assault of nature itself. We call these forces the unseen enemies. And their primary weapon is time. Water. It is the giver of life and the ultimate destroyer of stone. The first, most pervasive attacker is rain. It seeps into every joint, every fissure, every tiny crack. Over centuries, this process is known as freeze-thaw cycling, perhaps the most insidious form of decay. As temperatures drop below zero, the trapped water expands by almost 10%. This expansion acts like a tiny, relentless wedge, gradually prying apart the mortar, cracking the stone, and weakening the entire structure from the inside out. It is a slow-motion explosion, repeated hundreds of thousands of times. But the assault doesn't stop there. Groundwater rises through capillary action, pulling destructive salts from the soil directly into the porous building materials. When this water evaporates, the salt crystallizes within the structure, exerting pressure that literally turns solid rock into dust. The Romans, masters of drainage, knew that if you couldn't beat the water, your structure was doomed. But even their systems decay, leaving their descendants to fight a losing battle against relentless moisture. We think of earthquakes as sudden, dramatic events, a terrifying 15 seconds of shaking. But the seismic threat to ancient structures is far more complex. These titans often sit on active fault lines, from the Mediterranean's collision zones to the Pacific Ring of Fire, where Inca fortresses stand. The single massive quake is a threat, yes, but equally destructive is the constant, low-level vibration, the microtremors. These continuous, subtle shakes induce structural fatigue. Every tremor, no matter how small, slightly stresses and flexes the material. Over 2,000 years, this cumulative stress on rigid heavy masonry can lead to the formation of invisible internal fractures that are just waiting for the next big shock to complete the collapse. A modern concrete structure might handle this stress for a century. An ancient one must handle it for 20 centuries. The fact that the temples of Greece and the citadels of Peru still stand is not just miraculous, it's a profound statement on their forgotten anti-seismic engineering. Consider the desert monuments, the pyramids, Petra. They face the wind, carrying the abrasive tool we call the sands of time. This is nature's sandblasting, a constant, grinding process that slowly strips away inscriptions, smooths out carvings, and erodes the protective outer layers of stone, exposing softer material beneath. Simultaneously, the sun and temperature cycles wage war. Thermal stress is an invisible hammer. Stone and masonry expand during the blazing heat of the day and contract sharply during the cold nights. This continuous expansion and contraction, minute by minute, day after day, year after year, puts incredible tension on the joints and bonds, eventually creating thermal cracks that allow the water and wind enemies to gain a deadly foothold. It is a war of attrition where every dawn and every dusk is an attack. The earth fights to reclaim what was taken. The seeds of trees and bushes find purchase in the tiny cracks created by the freeze-thaw cycle. Once established, their root systems act as immensely powerful hydraulic jacks, splitting apart foundations and crushing walls. Look at the temples of Angkor Wat, where massive tree roots seem to swallow the stonework whole. Then there are the chemical pollutants, from the natural, like bird guano and mineral deposits, to the modern scourge of industrial air pollution. Acid rain, a product of our own industrial age, actively dissolves the calcium carbonate in marble and limestone, slowly turning intricate sculptures and protective facades into a coarse, eroded shell. The air we breathe is now accelerating the destruction of monuments that survived empires. As devastating as nature is, history reveals that the single greatest threat to ancient structures is the human factor. Not just the wars and sieges, though they are terrible, but the slow, methodical dismantling for raw materials. The Colosseum was plundered for 2 centuries, its stone used to build Renaissance palaces and churches. The Great Wall was cannibalized by local villagers for housing materials. In the modern era, the threat is often neglect, vandalism, and unchecked development. Urban sprawl encroaches, climate change shifts coastlines and accelerates weathering, and mass tourism, while necessary for funding, ironically speeds up wear and tear. Yet despite this constant, 4-pronged assault by nature and the final devastating blow by human hands, these titans endure. They stand as battered, beautiful, unyielding champions. We are about to reveal the forgotten genius, the secret weapons they used to win a war that should have been unwinnable. We have faced the enemies, the freezing expansion of water, the relentless grind of wind, the terrifying fatigue of seismic energy. The question is no longer how are they still standing, but what did they know that we have forgotten? Forget everything you think you know about ancient technology. We're about to expose the mind-bending reality that these civilizations built structures more robust, more inherently resilient than anything we often construct today. Their survival was not a fluke, it was a feature. It was intentional resilience built into the very DNA of the structure. Modern engineers believe in rigidity. Lock the structure down, make it strong enough to resist the force. The ancients often took the opposite approach. They built to dance. Their first secret weapon was a profound understanding of seismic activity. Consider the dry stone masonry of the Inca at Machu Picchu. Their walls are famous for their flawless interlocking stones, cut so precisely that you cannot slide a credit card between them. But this precision isn't about stiffness, it's about flexibility. When an earthquake strikes, these stones don't shatter. Instead, they momentarily unlock, absorbing the kinetic energy, subtly shifting, and critically, they settle back into their original, stable configuration once the tremor passes. They bend without breaking. We see this same principle in completely different cultures. Look at the ancient Japanese pagodas. These wooden towers, built over 1,000 years ago, are remarkably earthquake-resistant, not because they are stiff, but because they are flexible. They incorporate a central pillar, or shinbashira, that acts like a counterweight or pendulum, decoupling the structure's movement from the ground's tremor. The floors sway independently, neutralizing the destructive energy. The lesson here is clear. When the earth shakes, the structures that survive are the ones that are designed to move. Remember, water was a silent killer? The genius of the ancients was transforming this enemy into a managed resource. Take the Roman aqueducts. These aren't just channels. They are masterworks of civil engineering designed to maintain a perfect, gradual slope for dozens of miles, preventing stagnation and controlling flow. Their arches weren't just decorative. They provided structural relief, allowing water to pass around the structure, rather than letting it accumulate and degrade the foundations. Or consider the city of Petra. Carved into sandstone, the buildings themselves should have been destroyed by flash floods. Yet the Nabateans engineered a system of sophisticated dams, cisterns, and channels that diverted torrential floodwaters around the city and stored them for dry seasons. They built for the worst-case scenario. Every single aspect, from the sloping of a roof to the alignment of a street, was a calculated attempt to shed water and keep the foundations dry. The health of the structure depended entirely on its ability to manage moisture. They lacked calculators, but they understood geometry better than almost anyone. Their third secret was the perfect selection of shape. The arch, the dome, and the pyramid are not just aesthetically pleasing, they are inherently superior load-bearing shapes. The arch, for example. Unlike a straight lintel that must bear all the weight directly in the center, the arch efficiently converts downward vertical forces into outward lateral thrusts, distributing the stress across the curve and down to the sturdy side abutments. This dramatically reduces the tension stress that causes modern materials to fail. The Pantheon's dome, one of the single greatest feats of ancient architecture, took this to its extreme. A perfect hemisphere that has stood for nearly 2 millennia because the geometry allows the load to be channeled seamlessly downwards. They understood that the perfect circle and the perfect triangle are inherently stronger than any manufactured material. This knowledge wasn't pulled from a textbook. It was forged through generations of observation and failure. These principles were developed through a relentless trial-and-error process. When a wall collapsed during an earthquake, they studied why it collapsed, adapted the design, and rebuilt it better. There was no instantaneous structural analysis software, only inherited wisdom and meticulous craftsmanship. Every stone mason, every laborer, every architect was part of a living knowledge chain that perfected techniques like staggering joints, using massive foundational stones to prevent settlement, and incorporating natural expansion joints. They passed down trade secrets that prioritized longevity over speed and mass over minimalist design. This commitment to craft resulted in an unwavering spirit, a structural integrity that came from a deep, almost spiritual understanding of the forces they were trying to master. The result of this genius? Structures that are often still the most energy efficient, the most climate appropriate, and the most structurally honest buildings in their regions. We've seen the principles: dynamic flexibility, hydrological mastery, and perfect geometry. But that's only half the story. Their resilience also lies in their materials. In the next section, we dive into the secret chemistry, the ancient miracle materials that literally gave these structures the power to self-heal and endure where our modern chemistry fails. We've seen their architectural genius, their mastery of seismic movement and fluid dynamics, but the most profound secret to their enduring legacy lies not in the shape of the structure, but in the very dust they used to bind it. They didn't just build with stone, they built with a forgotten chemistry, materials that somehow gained strength over millennia, that healed themselves, and that laughed in the face of saltwater corrosion. We call these the miracle materials, and at the top of the list sits the legendary invention of the Roman Empire, Opus Caementicium, or Roman concrete. For centuries, modern engineers dismissed Roman concrete as primitive. They used lime and rock, simple ingredients. But the Romans had a secret ingredient that is baffling scientists even today: volcanic ash, or pozzolana. When mixed with lime and seawater, this ash undergoes a unique chemical reaction that continues long after the concrete has hardened. Modern concrete, the stuff we use in our skyscrapers and bridges, is strong but rigid. It fails when water seeps into microcracks, causing rebar to rust and the concrete to eventually spall or flake off. But Roman concrete is different. When seawater penetrates a tiny crack, the pozzolana and lime reactivate, forming a calcium aluminium silicate hydrate compound, a dense mineral phase that actually grows and fills the gap. This material is literally self-healing. Imagine a harbor wall standing for 2,000 years, continually battered by the corrosive, salty ocean. Modern concrete structures last maybe a century in that environment before needing major repairs. Yet Roman jetties and breakwaters are still intact. Their material wasn't designed to merely resist decay, it was designed to improve with age. It turned its greatest enemy, seawater, into its greatest ally. This is not just construction. It's an active, long-term geological process captured in a building material. Now, let's pivot from the Romans' sophisticated chemistry to the sheer power of human craftsmanship. The Inca of South America mastered a construction method that required no mortar, no cement, and no chemical reaction whatsoever: dry stone masonry. Their walls, such as those at Machu Picchu or Ollantaytambo, look like giant, flawless jigsaw puzzles. The builders didn't just fit the stones, they carved them to interlock in 3 dimensions, creating a tight bond that didn't rely on binding agents. This craftsmanship served 2 monumental purposes. First, it provided unmatched structural stability against lateral forces. It's nearly impossible to push a stone out because it's physically locked in place by its neighbors. Second, and crucially for their earthquake-prone region, it gave the wall a dynamic flexibility. The joints were so tight, yet so complexly angled that when the ground shook, the stones could rub against each other, absorbing the shock like structural cushioning, without dislodging. As soon as the tremor subsided, the sheer weight of the stones settled them back into their original, stable position. This wasn't merely building, it was stone tailoring. This method prioritized precision and patience over speed and cheap materials, a lesson we seem to have entirely forgotten. The materials were only as good as the builders who used them. Ancient construction mastery extended to simple, elegant techniques that guaranteed longevity. One key concept was mass and minimal joints. The Egyptians, for instance, used massive stones, weighing tons, at the base of their structures. This sheer mass prevented shifting and sinking into the foundation, countering the forces of settlement and uplift. Fewer stones meant fewer joints, and fewer joints meant fewer entry points for water and decay. Another technique was staggering joints, a simple but vital technique of overlapping successive layers of stone or brick. This distributes the load evenly and prevents a single, continuous line of weakness from running through the structure, which is often what causes walls to buckle or collapse. It's an easy concept, but flawlessly executed on a monumental scale over thousands of miles, such as sections of the Great Wall of China. And finally, the use of specialized foundations. Many ancient builders placed their structures on thick, deep layers of crushed stone or even charcoal, which help drain water away from the base, preventing the capillary action that destroys walls from below. They were building robust, dry platforms long before they even started laying the first structural stone. What these miracle materials and master techniques reveal is a fundamental difference in philosophy. We build fast, cheap, and disposable, relying on complex maintenance schedules to sustain the structure. They built slow, meticulously, and with a vision for eternity. They understood that the upfront investment in quality materials, whether it was self-healing concrete or flawlessly carved stone, would yield dividends for 2,000 years. The Roman chemist, the Inca stonemason, the Egyptian pyramid builder. They were not just building buildings, they were engineering time capsules. We've seen how they built. Now let's apply these lessons to the structures that have survived the ultimate test: millennia of existence. It's time for the case studies. We have uncovered the blueprints, the genius of dynamic engineering, and the secret chemistry of self-healing materials. Now it is time to witness these principles in action. For these structures are not just enduring. They are champions that have stood against the seemingly insurmountable odds of time, war, and the earth itself. They are our ultimate case studies in resilience. Our first stop is Rome, and a building so architecturally perfect it feels extraterrestrial. The Pantheon. For nearly 2,000 years, its massive dome, the largest unsupported concrete dome in the world, has remained essentially uncracked. Why? It's the perfect synergy of geometry and the miracle material we just discussed. Remember Roman concrete? The Pantheon is the ultimate showcase. As the dome rises towards the oculus, the builders drastically change the mix of the concrete. At the base, where the load is greatest, they used heavy aggregate like basalt and ceramic bricks. But as they neared the top, they transitioned to much lighter materials, primarily volcanic pumice and tufa. This reduced the overall load on the dome by hundreds of tons, minimizing tensile stress. Furthermore, the design incorporates a crucial engineering trick: the massive central opening, the oculus. Many believe this opening is merely for light, but structurally, it serves as a gigantic stress relief joint. It removes the heaviest, most complicated section of the dome, allowing the remaining structure to settle and withstand stresses without catastrophic failure. It is a masterpiece of material science and calculated weight reduction that has defeated gravity and the ravages of time for 20 centuries. Next, we travel to the Andes Mountains, one of the most seismically active regions on Earth. The Inca city of Machu Picchu sits directly above two major fault lines. This city is subjected to major earthquakes several times a decade. Logically, it should have been rubble centuries ago. Yet its core structures remain perfectly aligned. The secret, as we briefly explored, is the mastery of dry stone masonry, applied with an absolute commitment to dynamic flexibility. The stones are carved with concave and convex curves, like structural puzzle pieces, that lock them together but allow them to move slightly under the force of a tremor. Imagine a boxer rolling with a punch instead of trying to block it rigidly. When a quake hits, the walls gently shift, dancing with the earth's rhythm. Once the shaking stops, the massive, perfectly fitted stones settle back into position. They didn't anchor the city to the ground. They engineered it to be a fluid, living part of the landscape. Their genius was recognizing that strength comes not from rigidity, but from the ability to adapt. Our final case study stretches across thousands of miles of incredibly varied terrain. The Great Wall of China. The wall is not a single structure, but a monumental series of structures, and its longevity lies in the builder's adaptability. Where rock was abundant, they built with stone. Where the terrain was flat and loess soil was common, they used rammed earth, a simple, dense material that cures and hardens over time. In other sections, they used baked brick, a high-tech, industrialized material for its time. They didn't have one magic formula. They had 1,000, adapting their materials and techniques to the local geology. Furthermore, the wall's construction often incorporated specialized lime mortars derived from sticky rice, a brilliant bioadditive that provided superior tensile strength and water resistance. The result is that some remote, ancient sections, though neglected for centuries, remain remarkably intact, demonstrating that local, pragmatic engineering triumphs over monolithic, one-size-fits-all designs. From the self-healing dome of Rome to the earthquake-dancing walls of the Andes, these structures serve as living monuments to human ingenuity. They show us that with foresight, meticulous craftsmanship, and respect for the natural environment, we can indeed build something that endures. But what do these lessons mean for our future? That is what we explore next, as we look at how the forgotten wisdom of the ancients is now providing the blueprint for building tomorrow. We started by asking a profound question. How do they still stand? We now know the answer. Through a commitment to quality, a profound understanding of natural forces, and the ingenuity to make materials that last. But these lessons are not just footnotes in history books. They are a blueprint for our future. In a world facing climate change, resource scarcity, and the need for truly sustainable solutions, contemporary architects and engineers are undergoing a massive reawakening. Scientists are actively studying Roman concrete, trying to replicate its self-healing capabilities to create modern infrastructure that requires less maintenance and lasts centuries, not decades. Urban planners are looking at the hydrological systems of Petra, realizing that water management and deflection are far more sustainable than fighting the water with pumps and dams. And in seismically active zones, we are returning to the ancient concept of flexibility, designing buildings with base isolation systems that allow them to dance with the earthquake, just like the walls of Machu Picchu. The enduring legacy of these structures is not simply their physical presence, it is their philosophical challenge to us. The ancients built slow, they built meticulously, and they built with a vision of permanence. They left behind more than just ruins. They left testaments to human perseverance and a deep, almost sacred respect for materials and nature. As you look at the world around you, we encourage you to appreciate the history and the genius embedded in every surviving arch, wall, and dome. Let these resilient titans be our teachers. Let us apply these timeless principles to build a future that also defies the sands of time.